for example number 4 out of your textbook, it gives us a circular, or a cone actually, and it says that its height is equal to the radius. So a cone has a circular base, and usually they have a height, but the height is the same as the radius, and this is the radius of the circle. And so let me read the whole example problem. It says grain is leaking through a hole in a storage bin at a constant rate of 8 cubic inches per minute. The grain forms a cone-shaped pile on the ground below. As it grows, the height of the cone always remains equal to the radius. If the cone is 1 foot tall now, how tall will it be in 1 hour? Okay, so its constant rate of change is 8 cubic inches per minute. And as the height of the pile increases, so does the radius. And the question is, if the cone is 1 foot tall now, how tall will it be in 1 hour? So the solution to this, first thing we got to do is we have to start off with the volume of the cone. So the volume of the cone, when it's a cone, it's a little different. It's 1/3 times the base times the height. And so the base is the area of the circle, which is pi times r squared times the height. But what did we say the height was? Well, we'll just leave it as h for now. Well, it says if the cone is 1 foot tall now, how tall will it be in 1 hour? Well, let's figure out how much volume that is. Okay. So that would mean that my height would be equal to 12, but that also means that my radius would be equal to 12, right? So we'd say 12 squared times 12, right? Which is really 12 cubed. So what we end up with is 1/3 times pi times 12 cubed, which if you plug that in a calculator is 576 pi inches cubed. Now here's the thing. This is the volume. And the volume increases at 8 cubic inches per minute, but it asks us about how much will it change in 1 hour. Well, how many minutes are in an hour? 60, right? So what I need to do is, how do I figure out how much the volume changes in 1 hour? What's the number? How much will the volume increase by? Well, we have our original volume, which is 576 pi inches cubed, plus 8 times 60 inches cubed. Is that right? So then that would equal, well, it's a pretty big number. 576 pi inches cubed plus 480 inches cubed. Now that's equal to the volume, and we want to know what? The height. So if I take my equation 1/3 times pi times r squared times h, but h is equal to r. Couldn't I say pi h cubed? Now, why would Mr. Adams substitute the r for the h? Well, they equal the same value, but the question asked me is how high will this be after 1 hour? So I'm going to write my formula in terms of h. Now, does everybody know where that h comes from? So the only thing I need to do next is, well, a little bit of math. The first step would be pi times h cubed, and then all this stuff times 3, right? Because if I multiply this by 3 and I multiply this by 3, these 3's cancel. Okay? Then the next step would be to divide everything by pi. And the last step would be to take the cube root of all this stuff. So if I say 3 times 576 pi plus 480 inches cubed all over pi. Now if you crank through the math, your final answer will be is that the h is equal to about 12.98 inches. Does that make sense? So how much does it actually grow in 1 hour? If it started at a foot and it's almost 13 feet after 1 hour, it only grows like an inch. Now how come they said the rate was 8 units per minute, but it only grew an inch? Well, because the unit they gave us was volume. And so the volume of this cone increased because the radius increased and the height increased, but the height was very small compared to the volume increase.